Your time is six.
So it'll be like 6:40 or like
Yeah,
6:30.
6:40. Yeah, 6:40. Okay. Okay. So yesterday we come to the GCF and LCM. We already know the concept of finding the both of them. So to find the greatest common factor, we first of all we factorize them and we find the greatest one. So the definition is greatest common factor is the largest number that is factor of common common factor of those two or more numbers. But in order to find the least common multiple, we do the multiplication of that number and we find the least common ones. But somehow, when we do like that, when we do, for example, this problem, it takes us about, let's say, 10 minutes or more than that to figure out the answer because the answer is big, right?
Yeah.
So I will tell you another way to find out the, the LCM and the GCF, which is faster and easier and less confusing. We know that if we do this multiplication and we miss at some point, then the whole answer will be incorrect.
Will be,
Yeah,
yeah.
and go like all the way again and
Ah, it's
again.
too hard.
Yeah, it's too hard. For example, this the last one is like until 500 something. So and
Yeah.
somehow you try to do it and try to do it, and then it's over 400 or 500. So I think maybe I cannot find it. Then it's come to the answer. So or like as as far as I remember, when we do number three, you make all the correct answer until the result.
Yeah.
You make the a little bit different, like incorrect answer, and then you cannot find the common one. So that also the problems. So in order to find that one, we have another option of choice of doing that. So for example, now to find the GCF, to find the GCF of 16 and 21, we usually make it the factor of them. But now we will do it by using the prime factors. Do you still remember the prime factor? The
It was like
at the
two,
yes.
3,
Okay, so
5,
let's do the prime factor. For example, the first, the first.
2, 1, 2.
So 16 here, two, three. 16. To do the prime factor is we can either do the number three like this, right?
Wait.
Prime factor, we do the number three and we find until the ends result is a prime.
Oh, prime factorization.
Yeah, prime factorization.
Oh, 4 and 4.
4 and 4, yes, four and
Yeah.
four, but four is not a prime yet, so
So
we still continue
4 into
two and
2
two, right?
times 2, 2, yeah.
And this also two and two. So the result of 16 is equal to
It's equal
2,
to 2 to the power of 4, right?
yeah, or 2 to the power of 4. But as we study in grade 6, we write this like 2 times 2 times 2 times 2, 4 times.
Yeah.
And another one is 21. Okay, now 21, 20. Okay, now the one is 21. What is 21 consist of?
7 times 3.
7 times 3. So we can write 7 times 3. Add 7 and 3 is already the prime factor.
Yeah, so we don't have to do anything else.
Okay. And then we try to find the common prime factors. Do we have common prime factor here?
The common
Now
prime
this
factor.
is only number two, number two, number two, number two, but 21 is number 3 and number 7. So which means there is no common prime factor, right?
Yeah.
Because 16 is consists of 2222, while 21 consists of 3 and 7. So there is no prime factors here, here, no common prime factor. So when there is no common prime factor, the result is 1.
Yeah.
0, it's 1. Okay, let's do another one because this is a little special case because it's no common prime factor. The other one is 48 and 128. Okay. Now let's do number 2 because number 2 we have the prime number. So 48 is consists of
Well, 4 times 12.
4 times 12, correct?
So
4
we have to
times
turn 4 into 2 times 2
2
and
times
12,
2, correct? 2 times
and
2,
12 into 6 times 2.
6 times 2,
We have to turn 6 times 2 equals 3 times 2 times 2.
3 times 2, right? 3 times 2
Oh,
is
yeah, 3 times 2. My bad.
okay. So 48 equal to 2 times 2 times 3 times 2 times 2, right? Here is the end result here, here, and here. So we have 2 times 2 times 3 times 2 times 2. That is the compose of the number 46,
Yeah.
48. Okay, let's do number 120, 128. Okay, now we do 128, which consists of
Which consists of. Oh, this one's hard, huh? Wait, let me find my paper.
128 consists of
120.
128.
Well,
Zero, what number and what number?
well, 128 divided by 2
Okay.
is 64, right?
Okay, so 2 and 64, when we make a
Yeah.
prime, 2 is already prime, but 64 is not. So 64, we can make it to,
64.
yeah, 64 is 1 and 1.
Well, 32.
32 and
2.
2, okay, 2 and 32. While 2 is prime, 32 is not prime, so we make it to,
Well, what if we just started over and put it as 32 and 4?
yes, it will be giving the same result.
Really?
Yeah, it will give the same. Okay, we will try to do this and we will check 32 and 4. If we do, for example, 128 equal to 4 and 32, then we break this into 2 and 2, right? Which is our result here, 2 and 2. And then the other side is 32 here, right? the same. So the result will be the same. No difference.
So 32 to 16?
Yeah, 2 and 16. 2 is primes, but 16 is not. So we break it more. 16 equal to
4 times 4?
4 times 4, yes, 4 times 4. And 4, both are not a prime number, so we break them together. 4, which is equal to, 4 is equal to,
4 is equal to 2 times 2, right?
yes, 2 times 2. 4 equal to 2 times 2. So that's all the prime number. This is prime number, this is prime number, this is prime number. All is prime number. Now, 128 is composed of,
128 is composed of 2 I
yeah,
to the
this 1
2 times
times 2
2 times 2 times 2 times 2 times 2.
times 2,
1, 2, 3, 4, 5, 6,
2.
7. 2 to the power of 7, right?
Yes, correct. So 2 to the power 1, 2, 3, 4, 5, 6, 7. Okay, let me delete this here. Okay, wait, I will delete this graph. Okay, that is our 7s. Now, after we do the prime factorizations already, we choose. Now, it's time to choose. What do we have in common as a prime factor? One.
What do they have in
Yes,
2?
this, yeah, okay. These
Just
two
2,
have in common. These two also have in common,
but
right?
not but not 3.
But not this. But how about this? Still have in common, right?
Yeah.
And
And then
the one
three,
is these pair, right?
2, yeah. But
How
now
about,
they don't have a anymore.
yeah, and then they don't have any more. So what they have in common is one of these two, and these two, and these two,
So they have 4 pairs.
which is four pair of two. So so that pair will be, this is two, this is two, this is two, this is two, four pair, right?
Yeah.
So 2 times 2 times 2 times 2 equal to,
2 equals 128, right?
no,
No, no, no, no.
2 times
The
2 is
4 times
4,
2 equals 8 times 2 equals 16.
16, right? That is this result.
Yeah.
Yeah, so we can find the GCF by making a prime factor, and the common prime factor is the result of the GCF.
Yeah.
Okay. This is another way to do it. Maybe sometime we use
They're both
these.
hard. They're both hard.
They're both right, yeah, but this is not confusing. Now let's look at the LCM. LCM is quite similar. If we use this method, it's quite similar, but we choose the different pair.
Okay.
Okay, okay.
2 times 2 times 2. 2 times 2. It's just the prime factorization on the 128 part that got me confused.
Yes, 128 part is, it's a big number. So when we do the prime, it's, yeah, we have a lot of numbers. Okay, now let's do the LCMs. LCM of 18, which consists of 18 is equal to what time one? Or consists of
18 equals actually 9 times 2.
9 times 2, yes. While 2 is prime, yes, okay, but 9
9
is
isn't. 9 is 3 times 3.
3 times 3. Now we have the prime number. So 18 equal to,
Equals 2, 3. No, 3 times
yeah,
3 to the power of 2 times 2.
times 2, yes. 3 times 3 times 2, or 3 to the power 2 times 2. Okay, now now we have 18. So let's do the other one. The other number is 42.
44.
42.
42.
Yeah,
Sorry, I was looking at the
42.
wrong one.
So 42 is composed of what number?
7 times 6.
7 times 6. And 7 is a
But
prime number already. How about 6?
isn't, so it's 3 times 2.
3 times 2. That's all. That is the
So,
prime number, right?
3 times 2 times 7.
3 times 2 times 7. Okay. Now, if we find the GCF, for example, if we find the GCF of 18 and 42, what factor do we take?
Huh?
If we find the GCF of 18, this question is LCM, but for example, because we already study about the GCF, when we break the prime number, when we find the GCF of 18 and 42, what will be the common prime factor we are taking?
3.
3, yes. So we have one pair in common. How about these 3? No. Do we have any other common pair of?
No.
How about these 2?
Oh, yeah.
Yeah. So the GCF of 18 and 22 will be 3
3
and
times 3 times
no, not 3
2.
times 3. We only choose the common factor. It means the common factor, right? Common factor.
So just 3
GCF
and 2.
is common factor. So the common factor that we have when we break the prime factor, we're taking into the result of the GCF.
Is it 3?
3, we have 3 and 2.
3 and 2.
Yeah, we have, yeah, 3 and 2. So the GCF of the 18 and 20 and 42 is 6.
3 times 2, right?
3 times
No,
2.
3 and 2.
Yes,
3 times
3 times 2, which is 6.
6.
Yeah, if you don't believe this method, you can try. You can try like break it into the factor, and then we choose the greatest one. Then it will be 6.
Yeah.
Okay. Now the question is asked about the LCM. To find the LCM is somehow similar. Now we have 3 as a comment and 2 as a comment, but these 3 and these 7 we don't have a comment. But even it have it don't have a comment, we still take it for the LCM. For GCF, we only take the common pair, which is 3 and 2. Right? But for LCMs, we take the commons we take as 1, the common pair we take as 1, Beside that, we take all of that.
Yeah.
These don't have a common. These don't have a common. We also take it as a result, even if they don't have the comments. But for the GCF, we take only the comments. But for
For
LCM,
the yeah, for GCF,
yeah,
take the comment. For LCM, take all of them.
all of them. But if they have the pair, we only take one terms.
Even for LCM.
For LCMs, if we have one pair, we take it as a one term.
Okay.
Beside that, we take everything.
So for LCM, if there's only
LCM, it will be 3 times 2 times 3 times 7.
for LCM we take everything, but if we have one pair, we only take the one pair.
If there's one common pair, for example, this 3 and 3, we only take one terms, which is
One what
term. Term,
term?
yeah, one term is only one number 3.
Okay.
Yeah, one number 3. And this we have common pair, which is 2 and 2. So we only take one term as well, which is only 2. One term.
Okay.
Beside that, which though they don't have a pair, we also take them, which is here 3 and 7, right?
Yeah.
So the result will be 3 times 2 times 3 times 7, which is equal to,
3 times 2 times 2 times 7.
yes, which is equal to
3 times 2 is 6.
6,
Times 3 is 18.
18,
Times 7 would be 120. Wait, is it 126?
yeah, 126, which is here. So your answer is correct, right?
Yeah.
So yeah, to find the LCM, we can use this method as well. So GCF only take the common pair. LCM common pair take as one term. Beside that, we take everything.
Yeah.
Okay. So let's try the last one together. Try this one. Wait. Okay, this is this point. Okay. Okay. Okay, let's do the last one together. So the LCMs here, to find the LCM, first of all, we break into the prime factor. 26 is composed of
Um,
26 composed of
2 times 13.
2 times 13. 2 is already a prime, okay. 13 is also a
Prime.
prime, so that's okay too. So 26 is 2 times 13. Right, 2 times 13. So now, how about 44? 44 is composed of
2 times 22.
2 times
22.
2, 22. While 2 is prime, so we take this.
22 isn't.
22 isn't, yes, so we break
We
it.
turn 22 into 11 times 2
Yes, 2 and 11. So 2 is a prime number. 11 is not.
is.
It's also a prime. Sorry.
Yeah.
It's also a prime number. So that is our result. So 44 is equal
So
to,
equal to 2 to the power of 2 times 11, right?
yes, correct. 2 times 2 times 2, 2 times 2 times 11. So, okay. Now, for example, if we happen to ask find the uh, GCF GCF of 26 and 44, what will be the result?
GCF of 26 and 44?
Yes, 26 and 44. GCF.
Well, just 2 times 2. Well, just 2 times
What
2, right?
what do we have in common pair? Only one, two, right?
Yeah.
13 we don't have common pair, 2 here don't have, 11 here we don't have. So the GCF we take only the common pair, which is only 2. So the
Yeah, and for
GCF,
LCM, don't we just take
yeah.
2 or something?
Now for LCM of 26 and 44, 2 we have in common, so we take it as one term, right? So we take
Yeah, just
this
2.
as one term. Beside that, these, and these, we take all of them,
We,
right?
we take all of them?
Yeah, we take all of them. Beside the common term, even beside the common term, we take all of them. For the common term, we take only one common. Like this is a common term, 2 and 2, but we take only one terms.
Okay, yeah.
Okay. Beside
So,
that, yeah, beside that, we take all of them. So here, 2, here, 11, and here, 13. So the result of the LCM equal to 2 times 11 times 13. It will be the
yeah,
big number. Okay, so 2 times 2, then what is the result? 2 times
then
2 times 11 times 13.
2 times 2 equals 4
Yeah, 2 times
times
2
11 equals 44.
is 44.
10 would be 4, 2. Would it be 572?
Yeah, 572. That is
Yeah.
our result. So this the same, right? So for some kind of big number, I think we can do this method is faster, right? Faster way. If we do like yesterday, it's take about 15 minutes or 20 minutes to figure out these 572. But if we have another method here, it's more convenient and more easier, right?
Yeah.
Does it look like more easier? Okay. So let me give you one exercise you to, and we can use this kind of method to figure out the answer. Sorry. Okay, so next ones, let's say find ETF and LCM of 36 and 77. Find the GCF and LCM of 36 and 77. That's for you.
36 and 77?
Yes, 36 and 77.
Okay. 36.
36 and 76.
Wait,
36
find the G.
GCF
Which one?
and LCM. Both. Find both. Find GCF and LCM of these two numbers.
Okay.
GCF and LCMs.
That's good. Alright.
Have you ever come to Cambodia?
Yeah, I did once.
Oh, only once?
Yeah, only one. Are you sure there's a GCF for?
36 and 77. Yes, we have. Or maybe not. If not, then we text. 36. Okay, maybe let's do it together. 36 is composed of
3 times 12,
3 times 12, yes.
and we turn 12 into 6 times 2,
6 times 2,
and then we turn 6 into 3 times 3.
3 times
No, 3 times 2.
2, yes. So all
Oh,
is a prime number.
now I found my mistake. Never mind. Sorry.
3 times 3 times 2 times 2, right?
3 times 6.
3 times 3 times 2 times 2. Okay, now another number is 77. 77, which composed of
3 times,
7,
which is 2 times 77.
7 no,
Oh
70,
no, 7 times 11. Oh my god.
yeah, 7 times 11. 7 times 11. So in order to find the GCF, GCF of 36 and 77, what will be the pair? Do we have the common pair?
No.
No, we don't have. So when we don't have the common pair, what is the GCF of 36 and 77? When we don't have the common pair, the result of GCS will be
1?
1. Yes, will be 1. Will be 1s.
Does that mean the LCM is 1 too, or
No.
I
Now,
no.
LCM, do we have common pair?
No.
No. If there's common pair, we take as 1 term. Beside that, we take everything.
Okay.
Beside that, we take everything. So we take 3, 3, 2, 2, 7, and 11. 3, 3, 2, 2, 7, and 11. So, what is the result of the LCMs?
Times 2 times 7 times 11, right?
Yeah, yes, yes.
3 times 3 equals 9, times 2 equals 18, times 2 equals 36. And I have to keep track of where we are. Sorry. Times 2 would be 72, times 7 would be 50.
7, 36.
Oh no, times 7 would be 50, 504.
504
Times 11 would be,
will
let me
be
see, 4, 0, 5. which it would be 5,544.
5,544.
Is that right?
Yes, that is correct. 505. 5,544. This is the LCM of 36 and 77. So if we know this method, it
It's
somehow
way easy.
very easy. Yeah. If you figure out the 5,544, you will like calculate again and again and again and again. Maybe you take like 40 minutes or 1 hours to figure out this answer.
Yeah.
And if you have mistaken at some point, then you will never find the results.
Yeah, but it's 6:40 run right now. Are you late?
Okay, okay. So
Are you?
let's wrap it up today. And sorry, I will going now, and I see you
Yeah.
tomorrow.